Vectors u is 1 minus 3, 2. To find the length of u is the modulus of u. The modulus of u is equal to 1 square plus 3 square plus 2 square all square rooted. That's the length of u. Length of u, that's the length of u. 1 square plus 3 square plus 2 square all square rooted. All right, and so the length of u is the square root of 40. Now the length of v is going to be equal to 2 square plus 1 square plus 5 square all square rooted. That's going to be equal to 2 square plus 1 square plus 5 square all square rooted. That's the square root of 30. Nice. Can leave it right there. It says find cos theta, where theta is the angle between u and v. So it didn't even want, it doesn't want theta, it just wants cos theta. Now cos theta, to write down the formula, you know that cos theta is equal to u dot v. So it's equal to u dot v over the length of u times the length of v. That's cos theta. That's going to work out to be u dot v in this case is going to be, let's look at u dot v. U dot v will work out to be 1 times 2, which is 2, plus minus 3 times 1 is minus 3. Then you have 2 times 5, so plus 2 times 5, which is plus 10, over the length of u times the length of v, which is the square root of 14 times 30. I'm just joining it as 1 square root. That will give me cos theta. So in other words, this will simplify to be 2 minus 3 plus 10 is 9. That is just 9 divided by the square root of 14 times 30, 420. So 9 divided by the square root of 420. That's cos theta. So therefore, cos theta is equal to, you can convert it to decimal if you wish, square root of 420, 9 divided by the square root of 420. Cos theta is 0.439. 0.439. That's the value of cos theta. Nice. Good. Next question. It says a point P of xy moves such that its distance from the x-axis is half its distance from the origin. Find the locus of the equation. Let me zoom in. I'm not seeing fully. A point P of x moves such that its distance from the x-axis is half its distance from the origin. Determine the Cartesian equation of P. Now, I can't just do question like this. I always have to see what's going on. I always have to do a little sketch. So I draw x on my y-axis to just get a sketch. You have some point P such that it's moving from the x-axis. This is the x-axis. This is the x-axis. And they're telling me that the x-axis, they're telling me that P moves such that its distance from the x-axis is half its distance from the origin. This is the origin. I'm going to call the origin O, and O is the point 0, 0. And you have some point P. It doesn't matter where P is, I'm just going to put P somewhere. Let's say this is the point P, and I know that the distance from the x-axis, so this distance to the x-axis, if this is the point P, the distance from P to the x-axis, P is the point XY. And so the distance of the point P from XY, that's just gonna be Y, going from Y being 0, because remember this point would be X0, and so the rise will give you the length. So the length is Y, and they're telling us that this distance is half the distance from the origin. So this distance to the origin, this is half of this distance. So this distance Y, and so this distance is 2Y. All right? And so hence find the locus. Let's find the locus now. I have a good idea of what's going on. They tell us that the distance PO is equal to the distance from the x-axis is half the distance from its origin. So they tell us that the distance PO is 2 times the distance from the origin. It's 2 times its distance from the origin. So let's call this point A just for reference. So PO is 2 times PA. Now, in general, the distance PO, it's gonna be, this is XY and this is the point 0, 0. So the distance of PO is the square root of X minus 0. So it's X squared plus Y squared. That's the distance PO. And it's equal to 2 times the distance of PA. Distance of PA will be just be Y. It's equal to 2 times. Distance PA is just Y, yeah. Okay. And so we can square both sides and say that X squared plus Y squared is equal to, when I square both sides, this becomes 4y squared. Then I can subtract 4y squared from both sides to get that this is just x squared minus 3y squared. That's the locus. This is the locus of P. All right, nice and easy. That's the locus of P. I just have to get a visual representation of what's going on. I love to see what is happening. Should practice it. Practice sketching what's going on. You can never go wrong. Nice. All right, part D. Part D tells us that the line has equation 2x plus y plus 3, and the circle has equation x squared plus y squared equal 9. Determine the points of intersection. It's a simultaneous equation. So make y the subject here. So y would be equal to, from equation 1, making y the subject, y is equal to minus 3 minus 2x. That's going to be y. And we can substitute into the circle. So substitute the line into the circle. And so that implies that when we substitute the line into the circle, we get x squared plus y is now minus 3 minus 2x all squared. That's equal to 9. So what we get is x squared this is now x squared plus minus 3 squared is 9 plus twice the product of the 2. 2 times 2 is 4. 4 times 3 is 12. So that's plus 12x plus last term squared 2x all squared is 4x squared. And so that is equal to 9. Okay, now that that is equal to 9, the 9s are going to cancel. X squared plus 4x squared is 5x squared. This is now 5x squared. This is now 5x squared plus 12x is equal to 0. And so we can factor out 5x. Factoring out 5x, we're left back with x plus 12 over 5 is equal to 0. You might wonder, why did I factor out 5x and not just x? It makes it easier for me to see that hence x equals 0 or x equal negative 12 over 5. Now, since we get that this is x, we can just find y now by plugging in x in here. So y is minus 3 minus 0, that's just minus 3, so y is minus 3. And then y here is going to be plug in negative 12 over 5, so we get minus 3 minus 2 times negative 12 over 5. That's positive 9 over 4, 9 over 5, not 9 over 4, 9 over 5. All right, nice. So the points of intersection, I like to put it as points. The points of intersection are 0, minus 3, and negative 12 over 5, comma 9 over 5. These are the 2 points of intersection. All right. Always give them a little statement to say that and that are the points of intersection. Nice and easy. So, not too bad. Nice. Okay. Now that we have this, let's see what's going on now. So the next part of the question. Oh, before we finish, let's just check it back. Just want to check to make sure the answer is correct. So minus 12 over 5 square plus 9 over 5 square. That's 9. Yep, the equation is correct. The points of intersection are correct. All right.